In the last video, we were looking at how to solve quadratic equations. We looked at a number of different examples. For example, x squared equals 9, where we could take the square root of both sides. We looked at an example like this, x squared plus 5x plus 6 equals 0, where we could factor both sides. And we looked at an example like this, x squared plus 2x minus 1 equals 0. And here what we could do is we used completing the perfect square. We left the video thinking about what happens when the leading coefficient. So when the leading coefficient is not 1, we need to use a different method. We're still going to use the completing the perfect square, we just need to add an intermediary step. So what we do is we're going to divide everything by the leading coefficient. So we'll divide by 2, and what we get is x squared plus 2x plus 1/2 equals 0. And then we follow through with our typical steps for completing the perfect square. We get x squared plus 2x equals negative 1/2. And then we think about, okay, well, what do we need to put in here to complete the perfect square? So we divide our middle term in half and square it. So 2 divided by 2 squared is 1. Add it to both sides. And then we can write it as a perfect square. So we get x plus 1 squared equals 1/2. All right, well, the last step here is just to square root both sides. And when we do that, we get x plus 1 equals plus or minus the square root of 1/2. Well, now to solve for x, we just move the 1 over, and we get that x equals negative 1 plus or minus the square root of 1/2. And we get two solutions. And notice what we want you to start noticing is that there's this plus or minus and a square root, and that's going to start coming up a lot. Let's look at another example. Let's look at this example here. This is going to be a slightly harder algebra, but we're going to do the same first step. We're going to divide everything by the leading coefficient. So we'll get x squared plus 5/2 x plus 1 equals 0. Move the c term over. So we get x squared plus 5/2 x equals negative 1. And then we need to complete the perfect square. So we divide the b term in half and square it. So we're going to get 25 over 4 and 25 over 4 here. Just so that we can see what we're doing, we're taking that b term, we're dividing it by 2, and then we're squaring that whole thing. And that's our method for completing the perfect square. Okay, so then we can rewrite the left-hand side as x plus 5/2 squared equals 21/4. So I just simplified this and wrote it as one fraction. Okay, now we have this as a square, so we can square root both sides. And we get x plus 5/2 equals plus or minus the square root of 21 over 4. And this leads to our final answer, where we have x equals negative 5/2 plus or minus the square root of 21/4. Again, it's following in the same pattern of this plus or minus a square root. So completing the perfect square, it has both some advantages, or an advantage, and a major disadvantage. The advantage is it works for all quadratic equations. Unlike factoring, we can always rely on this method of completing the perfect square. The disadvantages, however, is just that it's slow and cumbersome. So ideally, we could create some sort of general solution for this method. So what I want to leave you with is thinking about this question. What if we had the quadratic equation just ax squared plus bx plus c equals 0? And we wanted to take this equation and solve it so that we got our general solution, x equaled something. How could we do that?